Starting to learn about quantum computing is like entering the future of technology, a new world where the usual rules of computing are replaced by the principles of quantum mechanics. This field can change industries by handling information in ways that today's computers can't. Quantum computing can solve complex problems much faster, making it essential for anyone who wants to keep up with rapidly evolving tech advancements. The potential of quantum computers opens up a new era of innovation and solutions. In this video, you'll learn what makes quantum computers different from regular ones, how they work, and their applications in cryptography and drug discovery. We'll also cover the challenges they face and their potential future impact on society and technology.
Quantum computers.
Quantum technology.
What on earth is a quantum computer?
Bits, qubits, try all the codes at once.
Quantum computing is a new way of computing that uses the principles of quantum mechanics, which is the science of very small things like atoms and particles. Unlike regular computers that use bits, which can be either 0 or 1. Quantum computers use qubits, which can be both 0 and 1 at the same time because of a property called superposition. The idea of quantum computing was first suggested by Paul Benioff in 1981, based on Max Planck's theory that energy, like matter, is made up of tiny, discrete units. Over time, his idea has grown with the advances in quantum physics, leading to the development of computers that work in a completely different way from traditional ones. One important feature of quantum computing is entanglement. This is when particles become linked, so that the state of one particle instantly affects the state of another, no matter how far apart they are. Because of this, quantum computers can handle many calculations at once, potentially solving problems that regular computers can't handle. Quantum computers use special algorithms that work in multiple dimensions. This makes them much better at solving complex problems like simulating molecules or optimizing large systems, which traditional computers struggle with. As more qubits or quantum bits are added to a quantum computer, its power increases exponentially. While traditional computers only get a linear power boost with more bits, quantum computing could revolutionize various fields. For example, it could crack encryption codes that are currently unbreakable, or help in drug discovery by accurately simulating complex molecules. However, the technology is still developing. Scientists are working on overcoming major challenges, such as reducing error rates and improving the stability of qubits to fully unlock the potential of quantum computing. How does quantum computing work? Quantum computers perform calculations using the probability of an object's state before it is measured, rather than just using ones and zeros. This allows them to potentially process much more data than classical computers. Classical computers perform tasks using the clear position of a physical state. They usually work in binary, meaning they use one of two positions, a single state, like on or off, up or down. 1 or 0 is called a bit. In quantum computing, instead of using regular bits, qubits are used to perform operations. Qubits are based on the quantum state of an object, like the spin of an electron or the polarization of a photon, which are properties that aren't clearly defined until they are measured. Instead of having a definite position, unmeasured quantum states exist in a mixed superposition, similar to how a coin spins in the air before landing. These superpositions can become entangled with those of other objects, meaning their outcomes will be linked mathematically, even if we don't yet know what those outcomes are. The complex math behind these entangled, spinning coins can be used in special algorithms to quickly solve problems that would take a traditional computer a long time, or might be impossible for it to solve at all. These algorithms can help solve tough math problems and predict how particles interact in chemical reactions. What makes quantum computers different from classical computers? Bits versus qubits. In computing, the main difference between classical and quantum computers is how they handle information. Just like I said earlier, classical computers use bits, which can be either 0 or 1, like a light switch being on or off. Quantum computers use qubits, which can be both 0 and 1 at the same time, because of a property called superposition. This allows quantum computers to do many calculations at once, making them much more powerful and faster than classical computers. Let's look at other differences: processing power and speed. Quantum computers are much more powerful than traditional computers. When you add more transistors to a classical computer, its processing power increases steadily, like one step at a time. However, when you add more qubits to a quantum computer, its processing power grows much faster, doubling with each new qubit because of a special property called superposition. This means quantum computers can handle far more complex calculations much more efficiently than classical computers. Quantum computers are good at doing lots of calculations all at once, which regular computers can't do. Regular computers have to do one thing after another to solve complicated problems, but quantum computers can do it all at the same time. This means they can solve problems super fast, like figuring out how molecules are built or making big systems work better. Quantum computers are super fast and powerful, but they're also delicate and need special conditions to work well. Unlike regular computers, they can be easily messed up by outside stuff. Plus, they're really expensive to set up and keep running smoothly. So, for everyday tasks like checking email or browsing the web, regular computers are still the way to go. But for super complicated stuff like simulating physics or managing huge systems, quantum computers are the champs. If you've made it this far, don't miss what's coming next. Make sure you hit that subscribe button to join our community and be the first to catch our newest and best videos. Let's continue. Applications of quantum computing. Number 1. Cryptography and cybersecurity. Quantum computing brings both problems and benefits to cybersecurity. Current encryption methods like RSA and elliptic curve cryptography are secure because they are hard for regular computers to break. However, quantum computers can use algorithms like Shor's algorithm to break these encryptions much faster. This means that data we thought was safe could become easy to hack, putting sensitive information at risk. To protect against threats from quantum computers, researchers are creating new types of secure communication methods called quantum-resistant algorithms. This area of study, known as post-quantum cryptography, focuses on designing security systems that quantum computers cannot easily break. Some examples of these new methods include lattice-based cryptography and hash-based signature schemes, which are being developed because they can resist attacks from quantum computers. Number 2. Drug discovery and material science. Quantum computing holds transformative potential for the pharmaceutical industry and material science. By simulating molecules, quantum computers can speed up drug discovery, which usually takes a lot of time and money. These computers can examine many molecular interactions at an atomic level, helping to predict how drugs will interact with the human body. Also, the ability of quantum computers to handle complex probabilistic calculations allows them to model quantum systems directly, such as the behavior of electrons within molecules, which is important for developing new materials and drugs. This capability could lead to breakthroughs in creating new materials and catalysts, as quantum mechanics governs the fundamental interactions within these systems. Number 3. Optimizing complex systems. Quantum computing can make solving difficult optimization problems much easier and faster, which is useful in many industries. For example, in logistics, quantum computers can improve supply chain management by finding the best delivery routes, cutting costs, and boosting efficiency. In finance, quantum computing can do a better job of optimizing investment portfolios than traditional methods. This is because financial markets are very complex and always changing. Quantum computers can look at many possible outcomes at the same time, which helps them make more accurate predictions much faster. In summary, quantum computing has many uses and can greatly improve things like cybersecurity, drug discovery, and optimizing complex systems. As technology gets better, it could change what we can do in various fields, leading to more innovation and efficiency. Despite all these, quantum computing still encounters a few challenges. Let's check out what these challenges are. Number 1. Decoherence. This is a major problem in quantum computing. It happens when quantum systems lose their special quantum properties because they interact with their environment. This loss of quantum behavior occurs when the system isn't completely isolated and starts to share information with its surroundings. Factors like noise, temperature changes, and electromagnetic interference can cause decoherence, making the quantum system act more like a classical one. For example, the materials and structure of a quantum chip can create noise, requiring more qubits to keep a logical qubit working properly and ensure reliable performance. Number 2. Error correction. Quantum error correction, or QEC, is essential for keeping quantum information accurate despite errors and interference. QEC works by spreading quantum information across many physical qubits to create a single, more stable logical qubit, protecting the data from noise. However, QEC is hard to implement in practice because it requires a lot of resources and many qubits, about 1,000 physical qubits for each logical qubit. Although researchers have made some progress in labs, they are still working towards a point where the advantages of QEC are greater than its resource demands. Number 3. Environmental conditions. Quantum computers need very controlled environments to work well. They must be kept at very low temperatures, almost at absolute zero, to keep the qubit stable. This cooling process uses a lot of energy and increases power consumption, which creates challenges for sustainability and environmental impact. Also, quantum environments are very sensitive to external factors, like magnetic fields and vibrations, so advanced shielding is needed to prevent interference. These strict requirements make it difficult to use quantum computing widely and show the need for ongoing improvements in system design and energy use. So, what does the future hold for quantum computing, and what are the current and upcoming innovations? Quantum computing is set to change many industries by boosting computing power and improving processes. For example, finance and pharmaceuticals are looking into how quantum computing can improve portfolio management and drug discovery. Additionally, quantum computing could greatly help with sustainability efforts and regulated industries by solving complex problems that current technology can't handle. By 2024, the focus on quantum computing is expected to shift from just increasing the number of qubits to improving their quality and error correction. This change shows the field is growing from experimental stages to practical, real-world uses. Also, quantum computing might start to be integrated into everyday devices, making the technology that supports our daily lives better. Recent progress in quantum computing has been impressive. Scientists have created a new hardware setup that connects thousands of qubits, making more advanced quantum systems possible. They also developed the smallest ever quantum light detector on silicon, which is a big step towards making quantum technology practical for everyday use. Innovations such as the use of machine learning to optimize quantum operations and the ability to maintain quantum information at room temperature for extended periods are making quantum computing more feasible and versatile. Also, the introduction of devices that process information with minimal light could lead to more energy-efficient quantum computing solutions. The field is also seeing advances in quantum materials, such as the use of hexagonal boron nitride, which is vital for developing quantum technologies due to its unique properties. These materials are very important for creating the next generation of quantum devices that are more stable and reliable. So, as quantum computing continues to evolve, the focus on enhancing error correction, reducing environmental sensitivities, and improving qubit quality will be highly important for achieving the full potential of this revolutionary technology. In the future, this technology could play a very important role in solving complex problems, such as creating new materials and even improving cybersecurity. Projections also suggest that by 2025, the healthcare sector's data generation will increase at a compound annual rate of 36%, outpacing manufacturing, financial services, logistics, and e-commerce by 6%. Leveraging quantum computing and AI to enhance model development could potentially improve illness treatment, mitigate financial risks, and enhance coordination. And that's a wrap on our journey through quantum computing. We've learned that it has the potential to change the game in areas like cybersecurity and medicine. Quantum computers are super powerful and can solve tough problems that regular computers can't. This amazing technology based on quantum mechanics is set to bring big changes and new ideas to many industries. So, looking ahead, quantum computing has a lot of potential. It's helping us improve error correction, reduce environmental issues, and make qubits better. As researchers keep pushing the limits, the impact on society and industries could be huge. Embracing quantum computing is not just about using new tech, it's about making the impossible possible and changing our world in incredible ways. There you have it, guys. What advancements can we expect from quantum computers by the end of 2024? And how will the landscape of quantum computing look by 2030? What do you think? Is quantum computing the key to our biggest challenges, or could it bring unforeseen issues? If you like the video, make sure to hit that like button and leave a comment about what you think. Share it with your friends too, and don't forget to subscribe to this channel.